So what's the integral of 1 over square root of 1 minus x squared? You just need to know that because we know that the derivative of arc sine is that. And so what's the integral of 1 over 1 plus x squared?
Arc tangent.
So those two you just need to know, okay? We've been talking about those derivatives for a while, especially the last couple of days, okay? Now, what's going to happen is that it might not be written that way. It might be written in different ways, and what you have to do is to use u substitution to make it look like it's one of those other ways, okay? It doesn't look like arc sine, but it has a square root and it has a minus. So if I made it look like arc sine, maybe it would be.
Maybe it's a real question.
Okay, so here's what I want to happen. I need the 4 to be a 1. Because in order for it to be arc sine, it has to be 1 minus something squared. Okay? So here's what I'm going to do. I'm not going to worry about that dx. I'm just going to leave it as a 1. That dx is out there to the side. I'm going to factor out the 4. And when I do that, I get a 1 minus, when you factor out a 4 out of x squared, that's x squared over 4. After you factor out the 4, then you can take the square root of 4 and take it out, because if you have two things multiplied underneath the square root, you can take the square root of each piece. Question so far? Or let's finish it. Okay, what this does, I want this to be arc sine. We've already talked about that. Now it's a 1 there. That's good. It's a minus. That's good. I need it to be something squared. So it's x squared over 4, so how do I make that something squared?
X to the 4th over 16.
Or how about just take the square root of each, because x squared and 2 squared make x squared over 4. I'm just like rewriting it to make it be the same. I'm not trying to square it out. You follow that? Okay, next. It looks like an arc sine problem. Okay? Because it's 1 over the square root of 1 minus something squared. But what has to happen is this has to be only like an x or only a u. So now I do u substitution. So the hard part here is that I have to rewrite all of that to get it to the form I want it to look like. Then I use u substitution the way we've done before. U is x over 2. So du is a half. And then here's the half, so I don't need to add anything in there. So this is the integral 1 over square root of 1 minus u squared, which is arc sine of u. And then I can substitute what u was. Okay, we're going to do another arc sine one. Do you agree that this looks like it could be arc sine?
Yes.
Eventually, yes. I need to get rid of that 5. I need that to be a 1. So we're going to do exactly what we did last time, which is what? Factor out of 5. Just like we did the square root of 4 last time, how we pulled it out, I'm going to pull out the square root of 5. But we don't know the square root of 5, so I'll leave it underneath there. I need it to be something in parentheses squared. I know that the x is going to be in there by itself, but what's the number going to be? Because the only way to get 2/5 when I square something is for it to be a square root. Because square root of 2/5 times square root of 2/5 is 2/5. Now I can use u substitution. So what's u? And then du is square root of 2/5. Now square root of 2/5, when you're dividing square roots, you can make it square root of 2 over square root of 5. So when I add it in, I can make it square root of 5 over square root of 2. Like I can separate it like that. And then my 1 over square root of 5 comes outside. One over square root of 2, because that goes away, of arc sine of u, and u was square root of 2/5 x. Just like we did on the arc sine, we pulled out the 16 because we need it to be 1 plus something squared. Alright, I can take that 1 over 16 outside of the integral, so I'm not really worried about it. And the thing underneath there, I need it to be something squared. So if it's a squared over 16,
X over 4.
it's x over 4. Because it's basically you're taking the square root of each of that to make it squared. It now looks like an arctan problem because it's 1 plus something squared. So I let u be x over 4, the thing inside the square, just like the arc sine one. du is 1/4. So you got to have that 1/4 in. I have to take that 4 out. So I get 1/4 the integral 1 over 1 plus u squared. And now it looks like arctan. Just because the bottom might look like arctan or arc sine doesn't mean that it is. The bottom there looks like something plus something squared, and we could probably manipulate it to make it look like that. But because there's a 2x on the top, that means that it's not going to be an arctangent problem. Okay. You can't take the 2x out. You can take the 2 out, but the x is still on the top. And the fact that that x is there, it makes it not necessarily be an arctan or an arc sine problem. So this problem is just a u substitution. So mixed in with some of the problems, there might be a u substitution problem, and I just wanted to show you so that you might recognize it. We have to have a 4x in there. We need a 4 in, which means that you need a 1/4 out. This 2, I'm going to bring it outside. So we have 1/2 integral 1 over u du, which is 1/2 ln of 4 plus 2x squared plus c. Okay, it is possible for there to be an x on top and it not be a u substitution problem. Let's say that was the problem. I know I can't use u substitution because if I did, I would have an x to the third. Because if u was 9 plus x to the fourth, I would end up with x to the third. There's not an x to the third there. That doesn't work. Okay? So let's try this tangent thing and see if we can figure out how to make this work. I'm going to not worry about the x yet, but I am going to factor out a 9. And then I need that to be something in parentheses squared. So what would that be if that's x to the 4th over 9? Now this 9, if you want to put it on the outside, you can, so that it's not confusing you. That is 1 plus something squared on the bottom.
Where'd you get the x squared plus 3?
I took the square root of x to the 4th and the square root of 9. Because I'm thinking backwards to make it be squared. Because if I squared it, I would get that. What would the u be if I'm doing an arctangent way?
X squared over 3.
So du is 2x over 3. And you see how that x, I need that x for the du? That's why that x is there. So just because there's x doesn't mean it's u substitution only. But I needed it there because of the du for the arctan. So then what the fraction is on the outside? So 1/9 times 3/2 times the integral 1 over 1 plus u squared, which is 1/6 arctan of x squared over 3.